Okay. Can I use LHopitals?
Yeah, because that's 1 over 0.
Which is what? What's virtually 1 over 0?
0.
Or
No.
it's infinity. As the bottom gets smaller and smaller, the whole thing gets bigger and bigger, correct? This infinity minus infinity?
Yeah.
It's an indeterminate form, so can I use LHopitals?
Yeah.
What?
Yes.
What?
Yes.
What? No. What's the other condition of LHopitals?
Oh, fraction.
It has to be a fraction. A fraction. I have 2 fractions. Do you see that? No, no, no. So, what do I need to do?
Common denominator.
Common denominator. Let's make it a fraction, right?
Yeah.
So let's first clean this up before I even do any derivatives. So I get the limit, x goes to 1. This one needs an x minus 1. This one needs a natural log of x. So I have x minus 1 minus natural log of x all over. I'm going to leave that factored. It may be cleaner, it may not be. We'll find out. Okay, so now what indeterminate form do I have? Plug it in. 0 over 0. Do we not get this idea? If I plug in 1, I'm going to get 0 up top, right? I want to get 0 at the bottom. So now I have an indeterminate form and 1 fraction. I can do LHopitals. So here we go. Do not drop your limit. So derivative of x is just 1. That's 0. That's 1 over x. Here, product rule, correct? Which says the first derivative of the second, which is 1 over x, plus derivative of the first is 1 times the second. Yeah? Okay. Let's see. Let's clean it up. Let's try. Can we plug it in? Because 1, I'll get 0 up top. I'll get 0 plus 0. So yeah, let's clean this up then. Instead of doing another derivative, let's see if cleaning it up will work. So up top I have x minus 1 over x. Yes? Common denominator. The bottom, I really have x minus 1 over x plus natural log of x. Right? So when I do a common denominator there, I get x minus 1 minus x natural log of x all over x. You with me there? We should be smooth sailing with those common denominators by now.
Yep.
That's KFC. I can at least cancel those x's. Don't you dare try to cancel those x minus 1s. This level we shouldn't even dare try that. Right?
Right.
Can I plug in now? Or what do I get when I plug in, I should say? 0 over 0. So, dang it. What should I do? Do it again. L'Hopitals rule again. Okay, so up top, the derivative is 1. The bottom, that derivative is 1. Then be careful. You have minus, you have to do the product rule here. So you better have parentheses, correct? So I have the first, derivative of the second, 1 over x. Derivative of the first is 1. The second, natural log of x. Let's clean that up. I have the limit, x goes to 1. 1 over, this will actually be 1 minus 1 minus natural log of x when I distribute my negative.
Yeah.
And when x times 1 over x is 1. Cancel. I have the limit, x goes to 1, 1 over negative natural log of x. I plug in now. Which is what? The bottom bottom gets smaller and smaller and smaller. The whole thing gets bigger and bigger and bigger. Yeah, I really should have a direction on these from the right to the left, but you get the idea. The key thing is the process right now. Yes?
Yeah.
So sometimes they're not always clean, they're messy, but